Number 1. We're asked to find the value of x, and we're told that triangle ABC is similar to PQR. Whenever you see the symbol for similarity, it prompts us to set up a proportion. So we can set up side AB, which is 4, over side PQ, which is 9, and that will equal side BC, which is 8, over side QR, which is 18. And we still haven't gotten our variable into this proportion, so we want to add another set of ratios. And that would be AC 10 over PRX. 4 over 9 and 8 over 18 will reduce to the same thing, so we can use either one of those in order to solve our proportion. I'm going to use 8 over 18. So cross multiplying, I have 18 times 10, which is 180, and that'll equal 8 times x, which is 8x. Dividing both sides by 8, I get 22.5 for x. Number 3, we have two similar polygons with a scale factor of 3 to 5. Once again, as soon as you see the symbol or see the word similar, it should prompt you to set up a proportion. We're going to use the scale factor, or the ratio of the sides, 3 to 5, in order to find out the perimeter of the smaller polygon. It says the perimeter of the larger polygon is 120 feet. Find the perimeter of the smaller polygon. Well, if you notice 3 to 5, 3 would represent the smaller polygon, 5 would represent the larger. So we're going to put the perimeter of the larger polygon, 120, on the denominator. And the perimeter of the smaller polygon will go on the numerator, and we'll call it x. So cross multiplying, we take 3 times 120, which is 360, and that equals 5 times x, which is 5x. Divide both sides by 5, and we get x equals 72. Number 4, to determine whether triangles are similar, remember we have 3 ways. There's side similarity, side similarity, and angle similarity. The first problem, they give us a set of parallel lines. At angle Y and angle Q, we have corresponding angles congruent. And angle X and angle R, we have corresponding angles congruent. So because we have 2 angles in one triangle congruent to 2 angles in the other, then these 2 triangles are similar by the angle similarity postulate. So when you have 2 angles in each triangle that are congruent, the 2 triangles are similar. For our congruency statement, we have triangle XZY. Well, X has 2 arcs next to it, so the next letter in our similarity statement should be R, which has 2 arcs next to it. Z has no arcs next to it, and Z is shared by both triangles, so Z would be our next letter. And then finally, Y has 1 arc, so it goes in the same position as Q, which has 1 arc. Number 7, they tell us that the 2 triangles are similar. So in order to find each measure, or find each variable, we're going to use our similarity statement to set up a proportion. We can take side JK, which is 16, and JK is the first 2 letters, so it's going to go over side RS, the first 2 letters, which is X. Side KL is 12, K to L, second and third letter, should go over ST, second and third letter, and ST is 3. To find x, we'll cross multiply. We have x times 12, which is 12x, and that equals 16 times 3, which is 48. We're going to divide both sides by 12, and we will get x equals 4. Number 13, this is the new stuff. Whenever you have two altitudes in both triangles, and you have two angles in each triangle that are congruent, you're going to have similar triangles. And the reason they're similar will be the angle-angle similarity. So our job is to match corresponding sides, or altitude over altitude, x over 9, which will equal side over side, 8 over 6. Cross multiplying, we get 9 times 8, which is 72, and that equals 6 times x, which is 6x. We're going to take 72, divide it by 6, so we get x equals 12. Number 15, this segment that has a length of 32 is a mid-segment. And the reason we know it's a mid-segment is because its intersection is at the midpoints of both sides of the triangle. So this is the midpoint of this side, and this is the midpoint of this side. So that means that this is the mid-segment of the triangle, meaning it's directly in the middle. Or it is half of the longer side of the triangle. So there's two ways to do this problem. You can say that the mid-segment, 32, is equal to half of the base, x plus 7. Or you can say that two of these 32s, or two mid-segments, make up one of the bases, x plus 7. Personally, I think this is the easier way to solve the equation, because then here you're going to be left with a bunch of fractions. So we're going to take two of the mid-segments, 32, and set them equal to one of the bases, x plus 7. 2 times 32 is 64, and that equals x plus 7. We're going to subtract 7 from both sides of our equation, so we just get x is 57.